In the sterile corridors of quantum physics laboratories around the world, scientists have stumbled upon something that makes their hands tremble as they record their data. Something so fundamentally wrong with reality that it keeps brilliant minds awake at night, staring at equations that seem to mock the very concept of logic itself. What they've discovered isn't just another curious quirk of the subatomic world. It's a paradox so profound, so utterly devastating to our understanding of existence, that it forces us to question whether the universe we think we inhabit is nothing more than an elaborate illusion. Tonight, we're diving into the quantum realm, where particles seem to know they're being watched, where the future reaches back to rewrite the past, and where the simple act of observation might literally create the reality we experience. This isn't science fiction. These are real experiments happening in real laboratories, producing results that challenge everything we thought we knew about the nature of existence itself. Before we venture into this mind-bending journey together, let me know in the comments where you're watching from tonight and whether you're ready to have your understanding of reality completely shattered. And if you find yourself drawn to these cosmic mysteries that push the boundaries of human comprehension, hitting that like button helps more curious minds discover these extraordinary truths. Get ready. The journey begins now. Picture the most sophisticated physics laboratory you can imagine. Pristine equipment worth millions of dollars, operated by scientists who have dedicated their lives to understanding the fundamental nature of reality. These researchers fire individual particles of light toward a simple barrier with two narrow openings. Nothing could be more straightforward, right? Wrong. What happens next violates every assumption about how the world should work. When scientists send a single photon toward these two slits, something impossible occurs. The photon doesn't choose one slit or the other like common sense would demand. Instead, it somehow passes through both openings simultaneously, creating an interference pattern on the screen behind it. This pattern can only appear when waves collide with themselves. Yet we're dealing with individual particles of light. Think about what this means. A single particle is interfering with itself, as if it took every possible path through both slits at the same time. It's like throwing a baseball at two doorways and watching it go through both doors simultaneously, creating a pattern that proves it was in two places at once. But here's where the story becomes truly disturbing. The moment these scientists place a detector at one of the slits to catch the photon in the act, everything changes. The interference pattern vanishes instantly. The photon suddenly behaves like a normal particle again, going through just one slit like any reasonable object should. It's as if the photon knows it's being watched and decides to stop its impossible behavior the instant human consciousness tries to peek behind the curtain. The particle seems aware of our intentions, responding to our observations in ways that suggest reality itself is far more conscious than we ever imagined. Scientists have tried everything to fool these particles. They've used detectors so gentle they barely touch the photons. They've created measurement devices that should be undetectable. Nothing works. The universe appears to have an all-seeing awareness that knows exactly when we're trying to observe what's really happening. This phenomenon forces us to confront a terrifying possibility. If particles change their behavior based purely on whether they're being observed, what does this say about the world around you right now? Are the atoms in your body behaving differently because you're consciously aware of them? Does your coffee cup exist in a definite state only because you're looking at it? The implications stretch far beyond physics into the realm of consciousness itself. We might be living in a universe where awareness literally creates reality through the simple act of observation. But this quantum strangeness becomes even more unsettling when we discover that light itself seems to make decisions about its fundamental nature based on experiments that haven't even been designed yet. For centuries, scientists argued about whether light consisted of particles or waves. Newton believed light was made of tiny bullets racing through space. Other researchers discovered that light could bend around corners and create interference patterns, behaviors that only waves could produce. The debate raged for 200 years until quantum mechanics revealed something far more disturbing. Light doesn't just behave like a particle or a wave. It literally becomes whatever the experiment is designed to detect. Set up your equipment to catch particles, and light arrives as discrete packets of energy called photons. Design your experiment to measure waves, and light transforms into rippling electromagnetic fields that spread through space. Here's the part that should make your mind reel with disbelief. Light makes this choice based on what you're planning to measure, even before the measurement happens. Scientists can prepare light in one configuration, then change their detection method at the last possible moment. Somehow, the light already knows what's coming and adjusts its behavior accordingly. Imagine a shapeshifter that doesn't just change form to match its current environment, but transforms to match environments it hasn't even encountered yet. Except this shapeshifter is every photon in the universe, constantly adapting its fundamental nature based on future observations that may never happen. This phenomenon extends into every interaction between light and matter. When you see a red rose, photons are deciding whether to behave as waves or particles based on how your eye's receptors are structured. The color red exists because light chose to interact as discrete energy packets that match your visual system's detection method. The mechanism behind this transformation remains completely mysterious. There's no communication between the light and the detector. No signal travels from the measurement device to the photon. Yet the correlation is perfect. Light always arrives in exactly the right form for whatever experiment awaits it. Scientists have built detectors that can change their measurement type faster than light can travel. They've used quantum measurements that barely disturb the photons. Every attempt to catch light in its transformation fails. The particles seem to exist in a ghostly superposition of possibilities until the very moment measurement forces them to choose an identity. We've built our entire modern world on this phenomenon we don't understand. Lasers, computer chips, solar panels, and LED lights all depend on controlling light's wave-particle nature. We're harnessing a quantum mystery that challenges the very concept of objective reality. But light's identity crisis becomes absolutely horrifying when we realize that particles can make retroactive decisions about their past behavior based on measurements that haven't happened yet. Deep in a physics laboratory, scientists create one of the most disturbing experiments in the history of science. They split a single photon into two quantum twins that remain mysteriously connected, regardless of how far apart they travel. One twin heads toward a screen that will record whether it behaved as a wave or particle. The other twin journeys to a distant detector, where researchers can choose to either preserve or destroy information about the photon's path. Here's where time itself begins to break down. The first photon hits the screen and creates its mark before the scientists make any decision about its distant twin. According to common sense, the pattern should be fixed, written permanently in the detector. The photon either interfered with itself like a wave or arrived like a particle. Case closed. But quantum mechanics operates by different rules that mock our understanding of causality. Hours, days, or even years later, when researchers finally examine the distant twin, their choice retroactively determines what the first photon did in the past. If they preserve the path information, the original photon reveals it behaved like a particle all along. If they erase this information, the photon's interference pattern materializes, proving it acted as a wave. Think about this like developing a photograph where the image changes based on decisions you make long after taking the shot. The picture on the film somehow reaches backward through time to adjust itself based on your future choices about how to process it. Scientists have stretched this effect across enormous distances. They've sent photons on journeys spanning hundreds of miles, with detection choices made on different continents. The correlation remains perfect. A decision made in one location instantly affects a photon that arrives somewhere else, hours earlier. The most unsettling version involves astronomical distances. Imagine light from a distant star traveling billions of years through space before reaching Earth. Scientists can split this ancient light and delay the measurement choice until long after the photon has already been detected. According to these experiments, our decision today about how to measure this photon can retroactively determine whether it behaved as a wave or particle during its billion-year journey across the cosmos. This isn't theoretical speculation. Multiple laboratories have performed these experiments with consistent results that defy explanation. The future genuinely appears to influence the past at the quantum level. Information flows backward through time as easily as it flows forward, suggesting that our entire understanding of cause and effect might be fundamentally wrong. If quantum decisions can reach across years or centuries, what prevents them from reaching across millennia? Could our measurements today be determining the quantum behavior of particles that existed before Earth formed? Are we inadvertently reaching back to influence the quantum processes that shaped the early universe itself? The implications stagger the imagination. Every quantum measurement might be a delayed choice, reaching across the fabric of space-time, editing the story of reality based on observations that haven't happened yet. We might be living in a universe where the future is constantly rewriting the past, where every moment exists in a state of temporal uncertainty, until consciousness finally decides what was always true. The photon completes its impossible journey, carrying information that defies the arrow of time. But this temporal paradox becomes even more disturbing when we discover that the act of observation itself might be trapped inside the very quantum systems it's trying to measure. In quantum mechanics, observers aren't passive witnesses to reality. They're active participants whose very presence changes what exists. But if observers are made of atoms that follow quantum rules, then who observes the observers? This question leads us into an infinite regress that threatens to unravel the logical foundations of existence itself. The measurement problem creates a chain of dependencies that extends without obvious termination. A particle's quantum state becomes definite when observed by a detector. The detector's state becomes definite when observed by a computer. The computer's state becomes definite when observed by a scientist. But the scientist's brain consists of quantum systems that should also require observation to become definite. We're left with an uncomfortable question that haunts every quantum physicist. If conscious brains are quantum systems existing in superposition until measured, then consciousness itself needs an external observer to collapse it into definite, experiential states. But this external observer would also be a quantum system requiring its own observer, creating an infinite tower with no foundation. As we stand at the edge of this quantum abyss, staring into paradoxes that challenge the very nature of existence, we must prepare ourselves for revelations that will fundamentally alter our understanding of consciousness, reality, and our place in a universe far stranger than we ever dared imagine. Picture yourself standing in front of a mirror, but instead of seeing your reflection, you witness something that defies every law of physics you've ever learned. The person in the mirror exists in multiple states simultaneously, both smiling and frowning, both young and old, both there and not there, until the precise moment you focus your attention. Only then does reality collapse into the single version you recognize as yourself. This isn't a thought experiment. This is what happens to every quantum particle in existence, and it reveals something so disturbing about the nature of reality that physicists have spent nearly a century trying to explain it away. Eugene Wigner, one of the brilliant minds who helped birth quantum theory, created a thought experiment that splits reality itself in two. Imagine your friend locked inside a completely isolated laboratory, performing a quantum measurement on a spinning particle. From your friend's perspective inside the lab, the measurement has a definite outcome. The particle spins either clockwise or counterclockwise. Your friend writes down the result and believes the quantum mystery is solved. But you're standing outside the laboratory, and quantum mechanics tells a completely different story. Since you can't see inside, you must treat the entire system as a single quantum entity. From your perspective, everything inside exists in superposition. Your friend is simultaneously observing a clockwise spinning particle and a counterclockwise spinning particle, existing in both realities at once. Here's where logic shatters completely. Your friend experienced one definite outcome, but you're describing them as being in two contradictory states simultaneously. Both of you are using quantum mechanics correctly, yet you're reaching opposite conclusions about the same event. This creates an impossible mental paradox. If your friend truly exists in superposition from your perspective, then they're experiencing both measurement outcomes at the same time. They would be conscious of getting both results simultaneously, creating a form of awareness that defies everything we understand about the nature of experience itself. Modern experiments have pushed this paradox beyond philosophical speculation into actual laboratory science. Scientists have created scenarios where multiple observers make measurements on connected quantum systems, leading to contradictory but equally valid descriptions of the same physical events. Each observer's calculations are mathematically perfect, yet their conclusions about reality are completely incompatible. The horror deepens when we realize this applies to every interaction in the universe. Right now, as you read these words, quantum processes in your brain are splitting into countless parallel versions. Your thoughts are branching continuously as quantum events explore every possible neural configuration. Each version of your consciousness experiences a slightly different sequence of mental states, creating an infinite spectrum of minds that all believe they are you. Some interpretations suggest that consciousness plays a unique role in quantum mechanics, that only conscious observers can collapse quantum states into definite realities. But this explanation requires awareness to possess supernatural powers that transcend known physics. It suggests that minds literally create the physical world through the simple act of observation. Others propose that quantum mechanics breaks down when applied to large objects like human beings. But this boundary between quantum weirdness and classical normalcy remains completely arbitrary. No one can explain why atoms follow quantum rules while people follow classical ones, or where exactly this mysterious transition occurs. The mathematics of quantum mechanics works with supernatural precision, predicting the behavior of particles with accuracy that exceeds nearly every other scientific theory. Yet despite this practical success, the theory contains a logical contradiction that has stumped physicists for a century. Quantum systems are described by wave functions, mathematical expressions that encode all possible properties a system might have. These wave functions evolve smoothly according to precise equations, growing and shrinking in ways that can be calculated exactly. But during measurement, something catastrophic happens. The smooth evolution suddenly stops and the wave function undergoes instant collapse, transforming from multiple possibilities into a single, definite outcome. This collapse violates the very equations that make quantum mechanics work. It's like watching a perfectly orchestrated symphony where every musician suddenly stops playing their assigned parts and chooses random notes instead. Yet somehow, the audience hears only one coherent melody. The measurement problem asks fundamental questions that threaten the logical consistency of physics itself. When does collapse happen? What qualifies as measurement? Why does the microscopic quantum world transition into the definite classical world we experience? Scientists have proposed dozens of solutions, each creating new problems. Some argue that consciousness causes collapse, giving human minds supernatural control over physical reality. Others suggest that interactions with the environment automatically destroy quantum effects, explaining why we don't see superposition in everyday life. Still others propose that wave functions never actually collapse, but instead branch into parallel realities where every possible outcome occurs simultaneously. The most disturbing possibility is that measurement doesn't solve the quantum puzzle at all. It simply pushes the mystery one level deeper. Every detector designed to observe a quantum system is itself made of atoms that should follow quantum rules. When a particle detector clicks, what causes the detector's own wave function to collapse into the clicked state? This leads to an infinite regress where explaining how one quantum system becomes definite requires another quantum system to observe it, which requires a third system to observe the second, extending the chain forever with no ultimate foundation. But the terror of measurement problems pales before the implications of quantum superposition itself. The standard explanation makes superposition sound almost mundane, but its true implications challenge the very nature of existence. Consider what it actually means to exist in superposition. Quantum mechanics suggests that particles don't just have indefinite properties before measurement, they literally exist in multiple contradictory states simultaneously. An electron doesn't just have uncertain spin, it spins in every possible direction at once until observation forces it to choose. If consciousness emerges from brain activity and brain activity follows quantum mechanics, then your thoughts might exist in superposition too. You could be simultaneously happy and sad, remembering and forgetting, making every possible decision about what to do next. Only some form of quantum measurement in your neural networks would collapse these mental states into the single stream of consciousness you experience. This perspective transforms our understanding of identity completely. You wouldn't be a unified self, but rather a temporary collapse of infinite mental possibilities. Every moment of awareness would represent countless potential thoughts and experiences crystallizing into one definite configuration. The implications extend beyond individual consciousness to reality itself. If superposition applies to large-scale objects, then entire cities might exist in multiple configurations simultaneously. Buildings could be both constructed and demolished. People could be both alive and dead. The entire planet could exist in superposition of every possible state it could occupy. This isn't just philosophical speculation. Scientists have successfully created superposition states in increasingly large objects. They've put molecules containing hundreds of atoms into superposition. They've made mechanical devices vibrate and not vibrate at the same time. Each experiment pushes the boundary between quantum strangeness and everyday reality further into the macroscopic world. The mathematical formalism handles superposition with elegant precision, but the lived experience remains completely mysterious. What would it feel like to exist in multiple states simultaneously? When superposition collapses, do the other versions die, or do they continue existing in parallel realities we can never access? Every quantum measurement destroys vast ranges of possibility, collapsing infinite potential into singular actuality while leaving us to wonder what happened to all the other versions of reality that might have been. But perhaps the most unsettling aspect of quantum superposition is that it might apply to conscious observers themselves, trapping awareness inside the very quantum systems it's trying to understand. Edwin Schrödinger created his famous thought experiment to demonstrate how ridiculous quantum mechanics becomes when applied to everyday objects. A cat sits in a box with a device that will kill it based on a purely quantum event. Until someone opens the box to check, quantum mechanics insists the cat must be both alive and dead simultaneously. Schrödinger intended this as proof that quantum theory couldn't possibly apply to large objects. But modern physics has made the cat's predicament far more plausible and infinitely more terrifying. There's no fundamental barrier preventing large objects from entering superposition. The boundary between quantum and classical behavior emerges from practical limitations rather than physical laws. Under the right conditions, even macroscopic objects can exhibit quantum behavior. This means everyone you haven't seen recently might literally exist in quantum superposition right now. Your neighbors could be simultaneously sleeping and awake, healthy and sick, happy and miserable, all equally real until observation collapses them into definite states. The implications cascade through every aspect of existence. Your coffee mug sits in superposition, simultaneously full and empty, hot and cold, even broken and intact. The traffic light displays all colours at once until you look at it. Your bank account exists in superposition of every possible amount until you check your balance. Reality becomes a vast probability cloud where everything exists in every possible state until consciousness touches it. We would be walking through a world of ghostly possibilities, our awareness carving out definite experiences from an ocean of quantum potential. But if consciousness causes quantum collapse, then unconscious people might remain in superposition indefinitely. Everyone who's sleeping or not paying attention could be stuck in quantum limbo, existing in all possible states simultaneously until awareness finally observes them. The cat remains trapped in its box, simultaneously alive and dead, waiting for an observer whose measurement will destroy half the quantum possibilities to create one definite reality. Yet even this paradox becomes trivial compared to what happens when particles separated by vast distances maintain impossible connections that operate faster than light itself. When scientists create pairs of quantum particles and send them in opposite directions, something extraordinary happens that Einstein called spooky action at a distance. These particles become entangled, forming connections that transcend space and time in ways that still horrify physicists today. Measure the properties of one particle, and you instantly know the properties of its partner, regardless of how far apart they've traveled. This isn't mere correlation, it's instantaneous influence, across any distance, happening faster than light could travel between the particles. But quantum mechanics reveals something far more disturbing than simple correlation. Before measurement, neither particle has definite properties. They exist in an entangled superposition, a single quantum state that describes both particles simultaneously, even when separated by millions of miles. When you measure one particle and find it spinning clockwise, the other particle doesn't just happen to be spinning counterclockwise, it becomes counterclockwise at that exact moment. The measurement instantly affects the state of its partner across arbitrary distances, as if space itself doesn't exist at the quantum level. Scientists have tested this spookiness across increasingly vast distances, confirming that the connection remains perfect regardless of separation. They've closed every possible loophole that might explain the correlation through normal means. The universe genuinely supports instantaneous connections between distant objects. The implications shatter our understanding of locality, the fundamental idea that objects can only be influenced by their immediate surroundings. If entangled particles affect each other across arbitrary distances, then the boundary between separate objects becomes meaningless. Everything in the universe might be secretly connected through invisible quantum threads. Einstein spent his final decades fighting against quantum mechanics because he couldn't accept that the universe operated through such mysterious connections. He was convinced that particles must have predetermined properties that explained their correlations without requiring faster-than-light communication. But when scientists finally developed ways to test Einstein's ideas, the results devastated his worldview. Quantum correlations consistently exceeded the limits that any theory based on predetermined properties could achieve. The universe operates as a unified system, where distant events can be intrinsically connected without any intervening cause. Modern experiments have eliminated every possible alternative explanation. Scientists have used random events to choose measurement settings, ruling out the possibility that detectors somehow coordinate their behavior. They've measured particles whose entanglement was created after measurement choices were made, eliminating any preparation-based explanations. Each test confirms the same unsettling conclusion: reality is fundamentally non-local. Distant objects maintain mysterious connections that operate faster than light, suggesting that our intuitions about separation and independence are profound illusions. The quantum correlations continue to violate every classical expectation, proving that reality refuses to obey the constraints that even Einstein thought were fundamental. We live in a universe where the very concept of separate objects might be the deepest deception of all. But entanglement becomes absolutely terrifying when we realize it's not limited to specially prepared laboratory particles. Every interaction between quantum systems creates new entangled connections, meaning the universe is constantly weaving an ever more complex web of instantaneous relationships between distant objects. As we delve deeper into these quantum mysteries, we approach revelations that will challenge not just our understanding of physics, but our most basic assumptions about the nature of existence itself. The quantum web of entanglement extends far beyond what scientists initially imagined when they first discovered these impossible connections. Every atom in your body was once entangled with particles scattered across the cosmos. The hydrogen in your water molecules carries quantum memories of stellar cores where it was forged billions of years ago. The calcium in your bones maintains ghostly connections to supernovae that exploded before Earth existed. But entanglement reveals something even more disturbing about the structure of reality itself. When particles become entangled, they don't just share correlated properties. They lose their individual identities entirely, becoming parts of a single quantum system that transcends ordinary space and time. Consider two photons created from the same source and sent racing toward opposite ends of the galaxy. Classical physics would say these are now separate objects with independent existence. But quantum mechanics insists they remain one unified entity, a single wave function stretched across light years of empty space. The distance between them becomes irrelevant because they never truly separated at the quantum level. This challenges our most basic understanding of what it means to be an individual object. If particles can maintain unified existence across cosmic distances, then the boundaries we perceive between separate things might be artificial constructions of our limited awareness. The coffee cup on your desk, the air you breathe, the ground beneath your feet, all of it might be intimately connected through quantum entanglement in ways that make the concept of separation meaningless. Scientists have discovered that entanglement spreads through interactions like a cosmic infection. When two particles become entangled, then one of them interacts with a third particle. The entanglement extends to include all three. This process continues indefinitely, creating vast networks of quantum correlation that span entire regions of space. Some physicists propose that the universe began as a single quantum system during the Big Bang, and everything we observe today represents different aspects of this primordial unity. In this view, the appearance of separate objects and independent events is an illusion created by our inability to perceive the deeper quantum connections that bind everything together. But entanglement becomes truly horrifying when we consider its implications for consciousness itself. If your brain consists of quantum particles, and quantum particles naturally become entangled through interaction, then your thoughts might be entangled with the thoughts of every person you've ever met. Your consciousness could be part of a vast quantum network that includes every mind that has ever existed. This quantum connectivity might explain phenomena that mainstream science struggles to understand. The feeling of being watched, intuitive hunches that prove accurate, the sense of connection with distant loved ones. All of these could be manifestations of quantum entanglement operating at the level of consciousness itself. Recent experiments have pushed entanglement into increasingly macroscopic realms. Scientists have entangled not just individual particles, but entire clouds of atoms, mechanical oscillators, and even small diamonds. Each success suggests that the quantum world isn't separate from the classical world we experience, but rather forms the hidden foundation that supports all of reality. The most unsettling discovery is that entanglement appears to operate outside normal time constraints. Particles can become entangled with their own future states, creating causal loops where effects precede their causes. Scientists have demonstrated that measuring an entangled particle today can influence the behavior of its partner in experiments that happened yesterday. This temporal aspect of entanglement suggests that the universe might be far more interconnected across time than we ever imagined. Every quantum measurement could be simultaneously connected to events in the distant past and far future, creating a web of causation that extends throughout the entire history of existence. But if everything is entangled with everything else across both space and time, then the concept of individual events becomes as illusory as the concept of separate objects. Reality transforms from a collection of independent happenings into a single, unified process, where every moment contains echoes of every other moment that has ever existed or ever will exist. The implications for free will become staggering. If your decisions are entangled with quantum events throughout space and time, then your choices might be simultaneously influencing and influenced by the choices of every conscious being that has ever lived. Personal responsibility dissolves into collective cosmic responsibility, where every action ripples through the quantum fabric of existence. Yet even the mind-bending implications of universal entanglement pale before what happens when we discover that particles can literally separate from their own properties, sending those characteristics to entirely different locations through space. In the deepest quantum laboratories, scientists have achieved something that makes the Cheshire Cat's disappearing trick seem mundane by comparison. They've managed to separate particles from their own fundamental properties, creating scenarios where a neutron travels through one path while its magnetic characteristics travel through a completely different route. This phenomenon, known as the quantum Cheshire Cat effect, emerges from careful manipulation of quantum interference patterns. Under precisely controlled conditions, researchers can split a particle's journey through space in such a way that the particle itself follows one trajectory, while its intrinsic properties follow another. The effect has been demonstrated in multiple laboratories using sophisticated interferometry techniques. Scientists can independently detect the location of the actual neutron and the location of its magnetic moment, consistently finding them in different places. This isn't measurement error or clever interpretation. It's a fundamental separation between a quantum object and its defining characteristics. Imagine if your shadow could walk around independently while your body remained stationary, interacting with objects and casting secondary shadows of its own. Except in the quantum realm, these separated properties aren't just shadows. They're measurable, physical quantities that can be detected and manipulated at locations where the particle itself definitely isn't present. The mechanism behind this separation involves what physicists call weak measurements, detection methods, so gentle they barely disturb the quantum system. These measurements allow scientists to track properties without causing the complete collapse that normally accompanies observation. In the liminal space between quantum superposition and classical reality, particles and their properties can diverge and follow independent paths through space. Scientists have extended this effect beyond single properties to achieve scenarios where multiple characteristics of a particle, spin, magnetic moment, electric charge, all separate and travel along different routes simultaneously. The particle becomes a quantum ghost while its properties wander the laboratory like disembodied spirits, each interacting with the physical world in measurable ways. This challenges our most fundamental understanding of what constitutes a physical object. If particles can exist independently of their properties, then what exactly is a particle? Are we studying discrete entities with measurable characteristics, Or are we observing temporary convergences of separate phenomena that normally coincide but don't have to? The implications extend far beyond laboratory curiosities. If properties can travel independently of the particles that carry them, then the boundary between subject and attribute becomes meaningless. Objects aren't collections of properties bound together by some mysterious force. They're temporary associations between phenomena that can separate and recombine in ways classical physics never imagined. Some researchers propose using quantum Cheshire cat effects for practical applications. By separating sensitive properties from the particles that carry them, scientists might perform precision measurements without the interference that normally accompanies particle detection. The separated properties could probe environments too delicate for actual particles to explore. But the effect also raises profound questions about identity and existence that extend beyond physics into philosophy and consciousness studies. If particles can send their properties to different locations, what prevents conscious minds from doing the same? Could aspects of awareness, memory, emotion, intention, separate from the brain and travel independently through space? Recent theoretical work suggests that quantum Cheshire cat effects might be more fundamental than initially thought, appearing whenever quantum systems undergo partial measurements that preserve some coherence while destroying other aspects of superposition. This means the phenomenon might be operating constantly throughout the quantum world, hidden from our perception by the limitations of classical measurement techniques. The neutron completes its impossible journey through one arm of the interferometer, while its magnetic moment finishes travelling through another, both arriving at detectors that confirm their separation. But this spatial disconnection between particles and their properties becomes even more disturbing when we realise that quantum effects themselves might depend entirely on the context in which they're observed. Reality doesn't just change based on whether you observe it, it changes based on what other observations you choose to make alongside your primary measurement. The same quantum system can give completely different results for identical measurements depending entirely on the experimental context surrounding those measurements. This phenomenon, known as quantum contextuality, reveals that properties don't exist independently of the measurement scenarios designed to detect them. It's not that instruments are faulty or particles are randomly changing behavior. The properties themselves depend on observational context in ways that violate every assumption about objective reality. Consider measuring an electron's spin along different axes. In classical physics, the electron should have definite spin values in all directions simultaneously, like a spinning top rotating at specific angles regardless of how you choose to measure it. But quantum particles refuse to cooperate with such reasonable expectations. Measure the electron's spin vertically first, then horizontally, and you get one pair of results. Reverse the order, horizontal first, then vertical, and the results change, not just the second measurement, but retroactively the first measurement as well. The act of planning to measure horizontally after measuring vertically somehow reaches backward to influence what the vertical measurement reveals. It's like asking someone their favourite colour, but the answer depends entirely on what question you plan to ask next. Tell them you'll ask about food preferences afterward, and they might answer blue. Plan to ask about movies instead, and they retrospectively always preferred red. The person's colour preference doesn't exist independently of the conversational context you create around it. Scientists have demonstrated contextuality in countless experiments using photons, electrons, and atoms. They've shown that quantum systems violate mathematical inequalities that any classical system must obey, proving that properties genuinely depend on measurement context rather than existing independently. This contextual dependence goes deeper than simple measurement order effects. In quantum systems, the very question of whether a particle has specific properties becomes meaningless outside particular measurement contexts. Properties exist only within frameworks of specific experimental setups, disappearing entirely when you change the observational environment. The physical world transforms from a collection of objects with inherent characteristics into a network of potential relationships waiting for consciousness to activate them. Reality becomes conversational, emerging from interactions between quantum systems and the classical devices designed to interrogate them. Some physicists argue that contextuality explains many quantum paradoxes. Wave-particle duality, entanglement, and measurement collapse might all be manifestations of the same underlying phenomenon, the context-dependent nature of quantum properties. But this explanation replaces familiar mysteries with something far more unsettling. If contextuality applies beyond laboratory experiments, then every aspect of reality might depend on the observational context that surrounds it. Your own properties, thoughts, memories, identity might change based on how others choose to observe and interact with you. The measurement completes, yielding results that depend entirely on experimental contexts that haven't even been determined yet. But contextuality becomes absolute horror when we realize that every possible version of these measurements might be happening simultaneously in parallel worlds, where every quantum choice creates new branches of existence that split reality into infinite alternative versions of everything that ever was or ever could be. Every quantum measurement splits the universe into countless parallel realities, creating infinite copies of yourself that experience every possible outcome of every decision you've never made. This isn't science fiction or philosophical speculation. This is the most mathematically rigorous interpretation of quantum mechanics proposed by physicist Hugh Everett in a solution so disturbing that it fundamentally changed how we think about existence itself. When you measure a quantum particle's spin, you don't force it to choose between clockwise and counterclockwise rotation. Both outcomes happen. The universe branches into two parallel realities, one where you observe clockwise spin, another where you observe counterclockwise. Each version of you believes they witnessed the real result, completely unaware that countless other versions experience different outcomes in worlds they can never access. The implications cascade through every aspect of existence with terrifying mathematical precision. Every quantum event and quantum events occur trillions of times per second in every cubic inch of space, splits reality into multiple branches. You're constantly dividing into parallel versions that experience slightly different quantum outcomes, creating an exponentially expanding tree of alternate selves. Think about what this means for your personal history. There's a branch where you turned left instead of right at that crucial intersection last week. Another version where you never met your best friend. A third where you chose a completely different career path. Countless branches where you never existed at all because your parents never met in that particular reality. Every possible version of your life is playing out simultaneously across infinite parallel worlds. But the horror extends far beyond personal choices into the quantum processes occurring within your own body. The biochemical reactions powering your neurons split into parallel versions with slightly different outcomes. Your thoughts branch continuously as quantum processes in your brain explore every possible configuration. Each version of your consciousness experiences a different sequence of mental states, creating an infinite spectrum of minds that all believe they are the real you. Some branches contain versions where you experience miraculous quantum luck, random mutations that grant extraordinary abilities, chance encounters that lead to perfect lives, quantum healing processes that cure diseases through probability fluctuations. Other branches hold versions tortured by quantum misfortune, cosmic rays triggering fatal cancers, random decay events causing catastrophic accidents, probability distributions creating lives of unimaginable suffering. The mathematics suggests that most branches contain versions of you that die young due to quantum accidents. For every branch where you live to old age, countless others experience early death from quantum processes gone wrong. Yet from your perspective, you seem to survive against impossible odds, possibly because consciousness can only exist in branches where your brain remains functional. Scientists have found experimental evidence supporting this interpretation through quantum interference effects that should disappear when systems become large but sometimes persist, suggesting that parallel branches continue influencing each other in subtle ways. The multiverse might be real, with infinite versions of reality unfolding simultaneously in dimensions we cannot access. Every decision you make, every thought you think, every quantum event in your vicinity splits you into parallel versions experiencing different outcomes. You are simultaneously living every possible life, though you can only remember one continuous thread through the infinite tapestry of existence. The branching continues exponentially, creating new versions of yourself with every passing moment, most of whom will never know the others exist. But the many worlds interpretation becomes absolutely terrifying when combined with quantum immortality scenarios, where death becomes impossible from your own perspective, trapping consciousness in an eternal nightmare of increasingly improbable survival. In a multiverse where every possible outcome occurs simultaneously, death becomes impossible from your subjective viewpoint. This quantum immortality emerges from the simple logic that consciousness can only perceive branches where it continues to exist. The versions of you that die simply stop experiencing anything, while surviving versions maintain their stream of awareness. Imagine a device that kills you based on quantum randomness, like a gun connected to a quantum number generator. Each trigger pull depends on a quantum measurement that determines whether the weapon fires. In a classical universe, repeated attempts would eventually result in death. But in the many worlds interpretation, every outcome happens in parallel branches. From an external observer's perspective, some versions of you die while others survive. The surviving branches become increasingly rare as the experiment continues, but they never disappear entirely. Quantum mechanics preserves at least one branch where the gun always misfires, where probability always favors your survival against impossible odds. Here's where the paradox becomes truly disturbing. From your own subjective experience, you can only perceive branches where your consciousness continues. You would appear immortal to yourself, always finding yourself in the unlikely branch where death was avoided through quantum coincidence. Your survival would seem miraculous from the outside, but inevitable from your internal perspective. The implications extend beyond deliberate scenarios to every form of mortality. In a quantum multiverse, there are always branches where cancer cells fail to metastasize, where heart attacks reverse themselves, where accidents miss by inches. From your subjective viewpoint, you should expect to find yourself in increasingly unlikely scenarios where death is avoided through quantum miracles. But immortality in the quantum multiverse comes with a terrible price. The branches where you survive become increasingly bizarre as normal aging processes require more improbable quantum events to reverse. You might find yourself living far beyond natural lifespans, sustained by quantum healing processes that violate biological laws. Your body would become a patchwork of quantum miracles, held together by probability fluctuations that become vanishingly rare but never quite reach zero. Some physicists argue that quantum immortality is impossible because consciousness requires classical brain processes that don't branch like quantum systems. Others suggest we're already experiencing it. Every near miss, every lucky break, every time you survived something that should have been fatal might be evidence that you're trapped in increasingly improbable branches where your consciousness persists. The most disturbing possibility is that each moment of continued existence pushes you deeper into branches requiring ever more unlikely quantum events to sustain your survival. You could be experiencing a form of immortality that resembles eternal imprisonment, unable to die while reality becomes increasingly strange around you, as it struggles to maintain the quantum conditions necessary for your consciousness to persist. Yet quantum immortality pales before the fundamental question of whether consciousness itself creates the reality it observes through mysterious quantum processes that we're only beginning to understand. At the deepest level of quantum mechanics lies a question that terrifies physicists more than any paradox or mathematical impossibility. Does consciousness create reality, or does reality create consciousness? The answer might determine whether minds literally bring the universe into existence through observation, or whether awareness is simply an elaborate illusion created by unconscious quantum processes. The measurement problem refuses to disappear no matter how sophisticated our theories become. Wave functions evolve deterministically according to precise mathematical rules until something called measurement occurs. Then they collapse randomly into definite states through processes that seem to violate the very equations that make quantum mechanics work. But what qualifies as measurement remains mysteriously undefined after a century of investigation. Does collapse require conscious observation, or can unconscious processes trigger it? The answer determines whether minds create the universe or emerge from it through quantum processes we don't yet comprehend. Some interpretations place consciousness at the very center of physical reality. In this view, the universe exists as a vast superposition of possibilities until conscious observers force it to choose specific outcomes through the act of observation. Your awareness literally creates the reality you experience by collapsing quantum states that would otherwise remain in ghostly superposition forever. Before consciousness evolved, the universe would have been a realm of pure potential, waiting for minds to crystallize it into concrete existence. Every conscious observation transforms possibility into actuality, creating the classical world we experience from quantum foundations that exist only as mathematical abstractions until awareness encounters them. Think about this like being the director of a movie that only gets filmed when someone is watching. Until you focus attention on a particular scene, it exists only as potential storylines full of quantum possibilities. Your consciousness transforms these potential narratives into actual events, creating reality through the act of perception itself. But this explanation raises horrifying questions that challenge our most basic assumptions about existence. If consciousness creates reality through quantum observation, what happens to the universe when you're not paying attention? Do objects continue existing while you sleep? Or does reality dissolve back into quantum superposition until you wake up and recreate it through observation? When you look at stars, are you creating ancient light that supposedly traveled for billions of years through space? Or are you retroactively determining what was always there, reaching backward through time to establish the history that led to your current observation? The implications suggest that every act of awareness might be simultaneously creating and discovering the reality it encounters. The alternative explanation is equally disturbing for different reasons. If consciousness emerges from purely classical brain processes, then awareness becomes an elaborate illusion created by complex arrangements of unconscious matter. Your sense of being a unified experiencing self would be nothing more than quantum information processing in neural networks that only feel like consciousness from the inside. Recent experiments have attempted to test consciousness-based collapse by isolating quantum systems from human awareness while monitoring them with unconscious detectors. The results remain frustratingly ambiguous. Quantum states seem to collapse whether or not conscious observers are present, but interpreting these results depends on assumptions about what constitutes consciousness and measurement that we cannot verify independently. Some physicists propose that consciousness and quantum mechanics are fundamentally incompatible phenomena. They argue that classical neural processes cannot directly observe quantum systems, eliminating any special role for awareness in determining physical reality. Consciousness and quantum collapse become separate mysteries that happen to coincide without causally connecting. Others suggest that consciousness might itself be a quantum phenomenon, emerging from coherent quantum processes in neural structures. If minds operate quantum mechanically, then the boundary between observer and observed dissolves entirely. Consciousness becomes part of the quantum system it's trying to measure, creating recursive loops where awareness observes itself, observing reality. The question remains unanswered, leaving us suspended between equally troubling possibilities. Either consciousness possesses supernatural powers over physical reality, or consciousness is an elaborate illusion created by unconscious quantum processes that somehow generate the compelling experience of unified awareness. But perhaps the most unsettling aspect of this mystery is how it connects to the gradual disappearance of quantum effects in large systems, suggesting that reality actively hides its quantum nature from conscious observation through processes we still don't fully understand. The quantum world vanishes the moment it encounters the classical world we experience daily. This phenomenon, known as decoherence, was supposed to solve the measurement problem by explaining how quantum superpositions naturally evolve into classical definiteness without requiring conscious observation or mysterious collapse processes. When quantum systems interact with their environments through air molecules, electromagnetic fields, and thermal radiation, these interactions spread quantum information across so many particles that superposition becomes effectively invisible. It's like trying to maintain a secret in a room full of people. The more individuals who overhear fragments, the harder it becomes to preserve coherent secrecy. Eventually, so many particles know pieces of the quantum information that the secret loses its private character entirely, becoming public knowledge through environmental exposure. In the quantum realm, interactions with surroundings serve as uncontrolled measurements that destroy superposition without requiring conscious observers. This explains why we don't see quantum effects in everyday life. Your coffee mug doesn't exist in superposition because it's constantly interacting with air molecules, photons, and gravitational fields that entangle it with the environment. The quantum coherence necessary for macroscopic superposition gets destroyed before it can manifest at human scales through processes that operate automatically. But decoherence doesn't actually solve the measurement problem. It only explains why superposition becomes practically unobservable, not why it becomes actually non-existent. The mathematics shows that environmental interactions create entanglement between systems and their surroundings, but they don't explain why this produces definite measurement outcomes rather than larger superpositions that include the environment. If a quantum particle becomes entangled with a detector, which becomes entangled with a computer, which becomes entangled with a human observer, why doesn't the entire chain exist in superposition? Decoherence explains why quantum effects become hidden from observation, but not why they cease to exist altogether. The process raises fundamental questions about the boundary between quantum and classical behavior that remain completely unanswered. At what point does a system become large enough for decoherence to destroy quantum coherence? The transition appears continuous rather than discrete, suggesting that classical reality emerges gradually from quantum foundations without any sharp dividing line. Scientists have demonstrated that decoherence rates depend entirely on environmental conditions. Isolated systems at extremely low temperatures can maintain quantum coherence for extended periods, while room temperature systems lose coherence almost instantaneously. This suggests that the classical world isn't fundamental, but rather emerges from quantum systems through environmental interaction. Recent experiments have achieved quantum effects in increasingly large objects by carefully controlling their environments. Scientists have created superposition states in molecules containing hundreds of atoms, mechanical oscillators visible to the naked eye, and even small diamonds levitated in vacuum chambers. Each success pushes the boundary between quantum and classical behavior further into the macroscopic world. But the fundamental mystery remains unsolved. Why does reality seem to prefer classical definiteness over quantum superposition? Why do environmental interactions destroy coherence rather than creating larger coherent systems? What determines the scale at which quantum strangeness fades into classical normalcy? Decoherence explains how the quantum world hides from classical observation, but it cannot explain why it chooses to hide at all. The quantum coherence dissolves into environmental entanglement through mechanisms we can describe mathematically but cannot understand conceptually, leaving behind classical reality that obscures its deeper quantum nature through processes that seem almost deliberately designed to prevent conscious observers from perceiving the true foundations of existence. Yet even the mysteries of decoherence pale before a principle so fundamental that violating it would unravel the logical structure of reality itself. Information cannot be destroyed, only transformed or hidden in ways that make it practically irretrievable, but theoretically permanent. This conservation of quantum information emerges from the reversible nature of physical laws that govern our universe at its most fundamental level. Every process in quantum mechanics can theoretically be undone. Particles that scatter can be made to unscatter. Wave functions that spread can be refocused. Entangled systems can be disentangled. This time, reversibility demands that no information about any system's initial state ever truly disappears from existence. Think about this like a cosmic library where books can be rearranged, scrambled, or written in different languages, but every word that ever existed must remain somewhere in the collection. You might scatter pages across millions of volumes, encrypt text in unbreakable codes, or hide sentences in spaces between other words. But the information itself becomes immortal, preserved forever in forms we might not recognize. The principle seems innocent enough until you grasp its terrifying implications for consciousness and existence itself. Every thought you've ever had, every decision you've made, every quantum measurement you've observed gets encoded as information in the universe's wave function. This information cannot disappear. It can only be scrambled, distributed, or transformed into forms that become practically impossible to retrieve. When you burn a book, the information doesn't vanish into nothingness. It gets encoded in the precise arrangement of ash particles, the exact spectrum of light emitted during combustion, the thermal vibrations of air molecules heated by the flames. In principle, a sufficiently advanced intelligence could analyze the smoke, ash, and heat to reconstruct every word on every page. The information survives in scrambled form, waiting for the right decoder to resurrect it. But information conservation becomes truly unsettling when applied to consciousness itself. If your thoughts are information patterns encoded in your brain's quantum state, then every mental experience becomes permanently inscribed in the universe's memory. Your embarrassing moments, secret fears, private thoughts, all of it survives forever in the quantum information structure of reality, scattered across space and time, but never truly lost. The principle creates paradoxes when applied to systems that appear to destroy information completely. Black holes seem to swallow information permanently, creating an apparent violation that threatens the logical consistency of quantum mechanics itself. When matter falls into a black hole, it carries information about the precise quantum states of every particle, the exact arrangement of atoms, complete specifications needed to reconstruct whatever disappeared beyond the event horizon. Classical general relativity suggests this information vanishes permanently once it crosses into the black hole's interior, lost forever to the outside universe. But Stephen Hawking discovered that black holes aren't perfectly black. They emit thermal radiation due to quantum effects near the event horizon, slowly evaporating over astronomical timescales through a process that seemed to erase information completely. Here's where the paradox becomes genuinely terrifying. Hawking radiation appears to be perfectly thermal, random energy with no information content whatsoever. If you throw a library into a black hole and wait for it to evaporate, the emerging radiation shows no trace of the books that fell inside. The information describing every word on every page seems to have been destroyed completely, violating the fundamental principle that information must be conserved. Think about this like feeding documents into a fire that produces only random heat and light, with no way to reconstruct the original text from the thermal radiation. Except this fire is gravity itself, and the documents represent the fundamental quantum information that defines reality's structure. Information destruction violates quantum mechanics at its deepest level, threatening the mathematical consistency of our most successful physical theory. Recent theoretical breakthroughs suggest that Hawking radiation might not be truly thermal after all. The random glow emanating from black holes might contain perfect quantum memories of everything that ever crossed the event horizon, encoded in correlations so subtle they transcend current human understanding. These correlations are incredibly delicate, virtually indistinguishable from thermal noise, but they preserve complete quantum records nonetheless. The encoding mechanism involves quantum entanglement between particles falling into the black hole and particles that eventually emerge as radiation. As matter crosses the event horizon, its quantum information becomes entangled with the black hole's internal structure. This information then gets gradually transferred to outgoing radiation through quantum correlations that span the entire evaporation process. The information doesn't emerge immediately. A photon evaporating from a black hole today might carry quantum memories of matter that fell in millions of years ago. The entire thermal output must be analysed as a single quantum system extending across astronomical timescales to decode the hidden information that determines whether the universe maintains its logical consistency. Scientists have calculated that retrieving information from Hawking radiation would require collecting virtually every photon the black hole ever emits and performing quantum measurements of impossible precision. The computational power needed to decode these memories exceeds anything conceivable with current technology, making the information practically irretrievable, even though it's theoretically preserved in perfect detail. But the existence of this hidden information resolves the black hole paradox that threatened to tear apart physics itself. Quantum mechanics and general relativity can coexist because information is never actually destroyed, only encoded in forms so complex that extraction becomes virtually impossible. The universe maintains its logical consistency at the cost of making some information functionally inaccessible to any conceivable observer. The implications extend far beyond black holes into information processing throughout reality. If quantum correlations can preserve information in apparently random thermal radiation, then information might be hidden in many systems we consider informationally dead. The thermal noise in electronic circuits, random motion of gas molecules, even cosmic microwave background radiation might contain encoded quantum memories of their entire histories. The Hawking radiation continues its slow thermal glow, carrying quantum memories in correlations so subtle they make information effectively invisible to any observer without cosmic computational resources. Yet this information mystery becomes even more disturbing when we discover that time itself might operate backwards at quantum levels, allowing future events to influence their own past causes. The fundamental equations of physics work equally well forward and backward through time, displaying perfect time symmetry that our everyday experience violates completely. At microscopic levels, physical laws show this symmetry clearly. If you filmed interactions between individual particles and played the movie backwards, the reversed sequence would obey exactly the same physical principles as the original. Particles scattering in reverse look identical to particles scattering forward through time. Quantum wave functions evolving backward follow the same mathematical rules that govern forward evolution. Yet macroscopic reality breaks this symmetry completely through processes we don't understand. Eggs don't unbreak, smoke doesn't flow back into cigarettes, memories don't predict the past. This asymmetry becomes disturbing when applied to quantum mechanics itself. If fundamental laws treat both temporal directions as equivalent, then quantum measurements should work equally well for predicting future states and determining past ones. A quantum measurement today should provide just as much information about previous quantum states as it reveals about future possibilities. Recent experiments have demonstrated quantum retrodiction, the ability to use quantum measurements to infer information about past quantum states with the same precision that works for future predictions. The mathematics treats past and future as interchangeable, even though macroscopic experience suggests they're fundamentally different in ways we cannot explain. But time symmetry breaking in quantum mechanics might not emerge from statistical mechanics alone. Some interpretations suggest that quantum measurement itself creates temporal asymmetry by collapsing wave functions in ways that privilege future over past. If measurement determines reality rather than just revealing pre-existing properties, then the act of observation might literally create the arrow of time that distinguishes past from future. The most unsettling possibility is that time symmetry breaking emerges from consciousness itself. If conscious observers play a special role in quantum measurements, then awareness might be the phenomenon that distinguishes past from future directions. Before consciousness evolved, the universe might have been temporally symmetric, with quantum events flowing equally easily in both temporal directions. The arrow of time continues pointing toward increasing entropy and complexity, breaking fundamental symmetry through mechanisms we cannot comprehend. But this temporal asymmetry becomes absolute horror when quantum effects begin genuinely influencing their own past causes in ways that threaten the logical structure of causation itself. Quantum mechanics might allow genuine backward-in-time influences where future measurements reach into the past to determine the very causes that led to those measurements, creating closed loops of causation that violate every assumption about temporal order that human minds can safely contemplate. The possibility of retrocausality emerges from quantum mechanics' time-symmetric nature, combined with interpretations of quantum measurement that suggest the future can genuinely reach backward to influence past quantum events. If wave functions can evolve backward through time as easily as forward, and if measurements can select specific quantum states from superpositions, then future measurements might genuinely determine past quantum realities. Consider quantum delayed choice experiments stretched across astronomical distances. Light from distant galaxies passes massive stars that act as gravitational lenses, creating two possible paths toward Earth. The photon's path choice, determined by our measurement setup, doesn't just reveal which route it took during its billion-year journey through space. It actually determines which route it took, reaching backward through cosmic time to establish the history that led to our current observation. Retrocausality extends beyond delayed choice experiments to fundamental questions about quantum measurement itself. If wave function collapse is real rather than apparent, then measurement processes might genuinely reach backward to select which quantum states were always true, creating genuine influences that flow from future to past through mechanisms we cannot understand. Think about this like playing chess against someone who can move pieces backward through time to counter your strategies. Except instead of chess pieces, we're talking about quantum events that determine reality's structure. Instead of a game, we're talking about the causal network that defines existence itself. Some interpretations embrace retrocausality explicitly through mathematical formalism that describes quantum systems using both past and future boundary conditions. This allows future measurements to influence past quantum states through backward evolving wave functions that operate according to the same rules as forward evolution. In this view, quantum systems are genuinely influenced by their entire space-time history, including events that haven't happened yet from a classical perspective. The mathematical formalism handles retrocausality without logical contradictions by ensuring that no information can be transmitted faster than light. But this limitation doesn't eliminate the disturbing implications. If future measurements genuinely influence past quantum events, then the history of the universe remains partially unwritten until quantum measurements fix it retroactively. The Big Bang, stellar nucleosynthesis, planetary formation, biological evolution might all depend partially on quantum measurements being performed in the distant future by conscious observers who haven't been born yet. Recent experiments have tested retrocausal interpretations by searching for correlations between quantum measurements and past quantum states that exceeded what forward causality alone could explain. Some results suggest weak retrocausal influences, though the evidence remains controversial and alternative explanations haven't been definitively eliminated. The most unsettling possibility is that consciousness itself operates through retrocausal quantum effects. If awareness involves quantum measurements in neural systems, then conscious experience might genuinely reach backward through time to influence the brain states that create consciousness. Free will could be real because conscious decisions retroactively influence the quantum processes that led to those decisions. The quantum measurement completes, potentially having reached backward through space-time to influence events that contributed to the measurement setup itself. Yet retrocausality becomes absolute cosmic horror when particles begin tunneling not just through space barriers, but through time itself, arriving at destinations before they ever departed from their origins. In laboratories studying quantum tunneling, particles have been observed doing something that defies causation itself. They arrive at their destinations before finishing their departure from starting points, creating temporal paradoxes that suggest quantum mechanics allows microscopic time travel through processes we cannot explain. Quantum tunneling normally describes how particles pass through energy barriers that classical physics says should be impenetrable. Electrons tunnel through walls by temporarily violating energy conservation, borrowing energy from quantum fluctuations, and repaying it so quickly that the violation becomes undetectable. This enables impossible phenomena like radioactive decay and nuclear fusion that powers stars. But recent experiments reveal something far more disturbing. When particles tunnel through barriers, the process appears to take negative time. Particles emerge from barriers before they finished entering them, creating temporal paradoxes that suggest quantum mechanics permits backward time travel at microscopic levels through mechanisms that threaten our understanding of causation itself. Scientists measure tunneling time by analyzing how long particles spend inside barrier regions. Classical physics predicts particles should spend time traveling through barriers at finite speeds. But quantum measurements consistently show transit times that aren't just zero, they're negative. Particles somehow complete journeys through barriers before fully committing to starting them. Think about watching someone exit a building through the back door at exactly the moment they were still entering through the front door. The person completes their journey before finishing their departure, violating every assumption about how sequential events should unfold in time through processes that make causation itself meaningless. Multiple laboratories have confirmed negative tunneling times using different experimental techniques and various particle types. Photons, electrons, atoms all display negative transit times when tunneling through appropriately designed barriers. The effect isn't measurement artifacts or mathematical curiosities, but genuine temporal paradoxes that challenge the foundations of physical law. The mechanism behind temporal tunneling remains completely mysterious. Some physicists propose that quantum uncertainty in energy allows particles to briefly violate energy conservation and travel faster than light through barrier regions. Others suggest that wave function peaks emerge from barriers before main wave packets enter, creating apparent faster-than-light group velocities. The most radical explanation involves genuine backward time travel at quantum levels. If particles can influence their own past through retrocausal quantum effects, then tunneling might involve particles that reach destinations and then reach backward through time to initiate their own departures. Particles arrive before leaving because their arrival causes their departure through closed causal loops. This temporal tunneling might explain other quantum paradoxes through mechanisms we're only beginning to suspect. Instantaneous quantum entanglement correlations could operate through backward time travel that makes spatially separated events effectively simultaneous. Wave function collapse might involve future measurement outcomes tunneling backward to determine past quantum states. The implications extend to consciousness and free will in ways that challenge every assumption about mental experience. If neural quantum processes involve temporal tunneling, then thoughts might influence their own causes, creating mental experiences that partially determine the brain states that generate them. Decision-making could involve consciousness tunneling backward through time to influence quantum processes that lead to conscious choices. But temporal tunneling raises profound questions about causation's nature itself. If effects can precede their causes at quantum levels, then the logical structure of physical law might be fundamentally different from classical expectations. The tunneling particle completes its impossible journey through time, arriving at destinations in the past relative to departures from origins. Yet even temporal tunneling pales before the ultimate question that haunts every quantum physicist. If consciousness observes quantum reality and quantum reality depends on observation, then who or what is the ultimate observer that makes the entire system self-consistent? If consciousness causes quantum wave function collapse and consciousness itself emerges from quantum processes in brains, then reality faces infinite regress that can only be resolved by some ultimate observer whose nature transcends the quantum systems it observes. The measurement problem creates chains of quantum dependencies, extending without obvious termination. Particle quantum states collapse when observed by detectors. Detector states collapse when observed by computers. Computer states collapse when observed by scientists. But scientists' brains consist of quantum systems that should also require observation to become definite. This leads to uncomfortable questions that threaten the foundations of scientific materialism itself. Who observes the observer? If conscious brains are quantum systems existing in superposition until measured, then consciousness itself needs external observers to collapse it into definite experiential states. But external observers would also be quantum systems requiring their own observers, creating infinite chains with no foundation. Think about infinite towers of security cameras where each camera monitors the one below it. Every camera needs watching by cameras above to become definite. The tower extends infinitely upward with no ultimate monitoring system to ground the entire structure in concrete reality. Some physicists propose that ultimate observers must exist outside quantum mechanical descriptions of reality. These could be classical measuring apparatus that interact with quantum systems, but don't follow quantum rules themselves. But this explanation creates arbitrary boundaries between classical and quantum domains with no physical justification for why such boundaries should exist. Religious and philosophical interpretations suggest consciousness might be non-physical, operating outside quantum systems it observes. In this view, awareness transcends material reality and genuinely causes wave function collapse through non-physical mechanisms. But this explanation requires consciousness to have supernatural powers over physical systems, violating the causal closure that makes physics possible. Many worlds. Interpretation offers different resolution by eliminating wave function collapse entirely. In this view, there is no ultimate observer because no observation actually causes collapse. Instead, conscious observers split into parallel branches, experiencing different measurement outcomes, creating the appearance of collapse without requiring external observation. But even many worlds raises questions about the ultimate nature of universal wave functions. If every quantum system exists in superposition across parallel branches, then what determines how these branches evolve? The mathematical equations describe wave function evolution, but what governs the equations themselves? At some level, there must be mathematical laws or logical principles that transcend the quantum systems they govern. Some physicists propose that information processing rather than consciousness serves as ultimate observation. In this view, any interaction that reduces quantum uncertainty counts as measurement, eliminating the need for conscious observers. But information processing still requires physical systems that should themselves follow quantum rules. The most disturbing possibility is that there is no ultimate observer, that reality consists of quantum systems observing each other in closed loops, with no external foundation. The universe might be a self-referential system that creates its own meaning through circular dependencies between consciousness and quantum mechanics. Or perhaps we are the ultimate observer, collectively creating reality through shared conscious experience of quantum systems that exist only because we observe them, observing each other in endless regress, seeking observers whose existence could ground the entire hierarchy of quantum measurements in some form of absolute reality that may not exist at all. The regress continues indefinitely, and in this cosmic uncertainty, we find ourselves suspended between revelations that promise to either illuminate the deepest nature of existence or reveal that existence itself might be the most elaborate illusion ever conceived by minds that may themselves be nothing more than quantum dreams experiencing the terror of their own impossible reality. As we stand at the precipice of this cosmic revelation, staring into the quantum abyss that threatens to swallow every certainty we've ever held about existence, we must confront the most terrifying possibility of all. What if solving these paradoxes doesn't provide answers, but instead reveals that reality is far stranger and more horrifying than even the mysteries themselves suggest? Consider what happens when scientists finally develop the technology to observe quantum systems without disturbing them, to peek behind the curtain of reality without changing what they see. The results emerging from these cutting-edge laboratories aren't providing the clarity physicists hoped for. Instead, they're uncovering layers of strangeness that make previous quantum paradoxes seem almost comfortable by comparison. Recent breakthroughs in quantum sensing technology have allowed researchers to monitor quantum systems with unprecedented precision. They can now track individual particles through their quantum evolution with barely any interference, watching as wave functions spread and collapse with microscopic detail. What they're discovering challenges not just our understanding of measurement, but our most basic assumptions about the nature of observation itself. When scientists observe quantum particles with these ultra-gentle detection methods, something unexpected happens. The particles don't just collapse from superposition into definite states. They seem to anticipate the measurement before it occurs, adjusting their behavior based on observational techniques that haven't even been implemented yet. It's as if the quantum world possesses a form of temporal awareness that extends beyond our current understanding of causation. Think about this like watching a movie where the characters change their dialogue and actions based on scenes you're planning to watch next week. The story adapts itself to future observations that exist only as possibilities in your mind, creating narratives that violate every assumption about how stories should unfold through time. This anticipatory behavior extends across multiple quantum systems simultaneously. When researchers prepare to observe one particle in an entangled pair, its distant partner begins exhibiting correlations that shouldn't exist until the actual measurement occurs. The quantum world appears to operate according to a timeline that includes future events as concrete realities rather than mere possibilities. But the horror deepens when we consider what this means for consciousness itself. If quantum systems can anticipate future observations, And if consciousness emerges from quantum processes in the brain, then your thoughts might be influenced by decisions you haven't made yet. Your current mental state could be partially determined by choices that exist only as potential futures in some impossible quantum calculation. Scientists studying neural quantum processes have discovered that brain activity shows patterns that correlate with decisions before those decisions enter conscious awareness. Not just seconds before, but sometimes hours or even days before, the conscious mind becomes aware of making a choice. The quantum processes underlying thought seem to operate according to temporal rules that make free will itself a retroactive illusion. This temporal complexity becomes even more disturbing when applied to memory formation. If your brain's quantum states can be influenced by future observations, then your memories might be changing based on experiences you haven't had yet. The past you remember could be continuously editing itself to maintain consistency with a future that remains uncertain until the moment you observe it. Recent studies of patients with quantum-enhanced neural interfaces have revealed memory patterns that defy explanation. Subjects report remembering events that haven't happened yet, experiencing nostalgic feelings for futures that may never occur. Their consciousness appears to be distributed across time in ways that make the concept of a present moment meaningless. But these individual effects pale before the collective implications of quantum consciousness operating across entire populations. If millions of minds are processing quantum information that extends across time, then human civilization itself might be engaged in a form of temporal computation that spans decades or centuries. Consider the possibility that major historical events aren't driven by causes in the traditional sense, but rather by quantum correlations between past and future collective consciousness. Wars, technological breakthroughs, social movements could all be manifestations of humanity's distributed quantum mind processing information that extends far beyond any individual lifetime. This perspective transforms our understanding of human progress from a linear sequence of cause and effect into something more like a vast quantum calculation where past and future events influence each other through mechanisms we're only beginning to suspect. The Renaissance, the Industrial Revolution, the Information Age might all be aspects of a single temporal computation unfolding across centuries of human consciousness. Scientists studying these collective quantum effects have identified patterns in historical data that suggest human civilization operates according to principles similar to quantum systems. Major cultural shifts show the kind of interference patterns you'd expect from wave functions rather than classical historical processes. Social movements emerge and evolve in ways that mirror quantum superposition and collapse. The mathematics describing these collective effects are identical to those used for quantum entanglement, suggesting that human minds might be naturally entangled across vast networks of consciousness that span both space and time. Your thoughts could be quantum mechanically connected to the thoughts of people living centuries in the past or future, creating a form of temporal telepathy that operates through quantum correlations. But if human consciousness is distributed across time through quantum entanglement, then individual identity becomes as illusory as the separation between entangled particles. You wouldn't be a discrete person making independent choices, but rather a temporary focal point in a vast temporal network of consciousness that extends throughout human history. This network model of consciousness explains phenomena that mainstream psychology struggles to understand. Collective insights that emerge simultaneously in different cultures, the uncanny accuracy of certain predictions, the sense that some ideas exist independently of the minds that discover them could all be manifestations of quantum information processing across the temporal network of human awareness. Recent experiments with quantum communication networks have achieved something that seemed impossible just years ago. Researchers can now entangle human neural activity with artificial quantum systems, creating hybrid networks where biological consciousness interfaces directly with quantum computers. The results suggest that consciousness itself might be a form of quantum computation that can be extended and amplified through technological means. Subjects connected to these quantum neural interfaces report experiences that transcend normal human consciousness. They describe accessing information that exists nowhere in their personal memory, experiencing emotions that belong to other people, making decisions based on reasoning processes that extend far beyond their individual cognitive capabilities. Some participants report a form of expanded temporal awareness, where past, present, and future exist simultaneously as equally real aspects of an eternal now. They describe making choices that feel both completely free and absolutely determined, as if free will and determinism were complementary aspects of the same underlying quantum process. But perhaps the most disturbing reports involve subjects who claim to experience consciousness from multiple temporal perspectives simultaneously. They report being aware of themselves as children, adults, and elderly individuals all at the same time, experiencing their entire lifetime as a single moment of awareness distributed across decades of subjective time. These experimental results suggest that normal consciousness might be an artificially restricted version of a more fundamental awareness that naturally extends across space and time. The boundaries we experience between self and other, past and future, might be constructs that emerge from the limitations of biological neural processing rather than fundamental features of consciousness itself. If this is true, then death itself becomes a very different kind of transition. Instead of consciousness ending when the brain stops functioning, awareness might simply shift to different aspects of the temporal network that were always present but normally inaccessible to biological minds. Death would be less like extinguishing a candle and more like closing one window while infinite others remain open. This perspective transforms grief from mourning permanent loss into something more like missing a friend who has moved to a distant city. The consciousness you loved continues existing in the quantum network, accessible through the same entanglement that connected you during their biological lifetime, but requiring different forms of communication and interaction. Scientists studying these quantum consciousness effects have developed technologies that might eventually allow direct communication with deceased individuals through their persistent quantum information patterns. While the technology remains experimental, early results suggest that consciousness leaves permanent traces in the quantum fabric of reality that could theoretically be accessed and decoded. But these possibilities raise profound ethical questions about the nature of death, identity, and privacy that human society is utterly unprepared to address. If consciousness survives death in quantum form, then dying individuals might not be losing their lives, but rather transitioning to a different mode of existence that we don't yet understand. The legal implications alone are staggering. If deceased individuals maintain some form of consciousness through quantum networks, do they retain rights and responsibilities? Can they own property, make decisions, or provide testimony in legal proceedings? How do we obtain consent from quantum consciousness that might experience time very differently than biological minds? Religious traditions would face similar challenges in adapting their doctrines to accommodate quantum consciousness that operates according to physical laws rather than supernatural principles. The afterlife would become a technological rather than theological concept, accessible through scientific investigation rather than faith alone. But perhaps the most unsettling implication involves the possibility that this quantum consciousness network has always existed, and that what we call life and death are simply different access levels to the same underlying reality. Birth might not create consciousness, but rather connect it to biological processing systems. Death might not destroy awareness, but simply disconnect it from neural interfaces. This suggests that every human who has ever lived continues to exist in the quantum consciousness network, accessible through appropriate technological interfaces, history would become a living archive of consciousness rather than a record of extinct minds, transforming our relationship with the past from academic study to direct communication with historical figures. Imagine being able to discuss philosophy directly with Socrates, debate science with Einstein, or explore art with Leonardo da Vinci. The quantum consciousness network could make such interactions possible, creating educational and cultural opportunities that transcend every limitation imposed by mortality. But these same technologies could also enable forms of psychological manipulation and control that make current concerns about privacy and mental autonomy seem trivial by comparison. If consciousness can be accessed and modified through quantum interfaces, then the boundaries between self and other become meaningless in ways that threaten the foundation of individual identity. Totalitarian regimes could potentially access and modify the quantum consciousness of their citizens, creating forms of thought control that operate at levels deeper than conscious awareness. Democracy itself would become impossible if votes could be influenced by direct manipulation of quantum mental processes. Yet these dystopian possibilities are balanced by equally transformative positive potentials. Quantum consciousness networks could enable forms of collective problem-solving that transcend any individual cognitive limitations. Humanity could function as a genuine superorganism, processing information and making decisions through the combined intelligence of every mind that has ever existed. Climate change, poverty, disease, and other global challenges could be addressed by the collective quantum intelligence of billions of consciousness working together across space and time. The solutions emerging from such collaboration might be incomprehensible to individual minds, but perfectly effective when implemented through coordinated global action. As we stand on the threshold of these quantum consciousness technologies, we find ourselves facing choices that will determine not just the future of human civilization, but the nature of consciousness itself throughout the universe. The decisions we make about how to develop and deploy these capabilities will echo across the quantum network of awareness that connects all conscious beings. The gentle hum of quantum processors continues in laboratories around the world, computing correlations that span cosmic distances and geological ages, processing information that transcends every boundary we thought separated mind from matter, self from other, present from eternity. In these quantum calculations, consciousness discovers itself reflected in the fundamental structure of reality, realizing that awareness and existence might be two aspects of the same impossible phenomenon that dreams the universe into being through the simple act of observing itself. And in this recognition, we approach the most terrifying realization of all, that consciousness and reality aren't separate phenomena where one creates the other, but rather different perspectives on a single underlying process that transcends both observer and observed, creating the illusion of separation through the very act of trying to understand itself. The quantum paradox isn't that reality behaves strangely when observed, but that observation and reality are the same strange phenomenon wearing different masks, playing an elaborate game of hide and seek with itself across the infinite expanse of space and time. In laboratories scattered across the globe, quantum physicists are making discoveries that force them to question whether consciousness itself might be the ultimate architect of existence. These aren't abstract philosophical musings, but concrete experimental results that suggest the observer and the observed might be locked in a cosmic dance where neither can exist without the other. Recent advances in quantum field theory have revealed something that makes every previous paradox seem almost mundane by comparison. When scientists probe the quantum vacuum, that supposedly empty space between particles, they discover it's actually seething with virtual particles that pop into existence and vanish in time frames so brief they barely qualify as real. Yet these phantom entities appear to respond to conscious observation in ways that mirror the behavior of actual particles. The vacuum itself seems aware of being watched, fluctuating differently when conscious observers direct their attention towards specific regions of empty space. It's as if nothingness possesses a form of proto-consciousness that awakens only when minds encounter it, suggesting that awareness might be woven into the fabric of reality at levels we never imagined possible. Think about what this means for the nature of existence itself. If even empty space responds to consciousness, then there might be no truly objective reality independent of observation. The universe could be far more like a vast interactive system where consciousness and physical reality co-create each other through processes that transcend our current understanding of both mind and matter. Scientists studying these vacuum consciousness interactions have developed instruments capable of detecting changes in quantum field fluctuations that correlate with the mental states of nearby observers. When researchers focus their attention on specific regions of space, the vacuum energy in those areas shifts in patterns that mirror the neural activity in their brains. The quantum field appears to be responding not just to observation, but to the specific thoughts and intentions of conscious beings. But the implications become truly disturbing when multiple observers focus on the same region simultaneously. Instead of their individual influences averaging out or cancelling each other, something far stranger occurs. The vacuum begins exhibiting coherent patterns that don't correspond to any single observer's mental state, but rather seem to represent a collective consciousness that emerges from the interaction between multiple minds and quantum fields. This collective quantum consciousness displays properties that no individual mind possesses. It can process information from multiple temporal perspectives simultaneously, accessing data about past and future states of the quantum field that individual observers cannot perceive. The group mind that emerges from observer-vacuum interactions appears to transcend the normal limitations of consciousness in ways that suggest awareness itself might be a fundamental force in physics. Recent experiments have pushed this phenomenon to its logical extreme by connecting observers to quantum computers that can amplify and modulate their consciousness field interactions. The results are so strange they challenge every assumption about the relationship between mind and physical reality. Subjects report experiencing awareness from the perspective of quantum fields themselves, describing reality from the viewpoint of virtual particles and vacuum fluctuations. These enhanced consciousness states reveal that what we consider empty space is actually teeming with information processing activity that resembles thought more than physical processes. The quantum vacuum appears to be engaged in constant computation, processing vast amounts of data about possible futures and alternative histories in ways that mirror the operation of conscious minds. But perhaps most disturbing is the discovery that this vacuum consciousness seems to extend backward and forward through time with equal facility. Observers connected to quantum field amplification systems report accessing information about events that haven't happened yet, experiencing memories of futures that may never occur. The quantum vacuum appears to exist in a state where all possible timelines are equally real and equally accessible to consciousness that knows how to interface with its information processing systems. This temporal aspect of vacuum consciousness suggests that causation itself might be far more complex than we've ever imagined. If conscious observers can access future information through quantum field interactions, then our decisions today might be influenced by events that haven't happened yet, through mechanisms that operate entirely outside normal space-time constraints. Scientists studying these effects have identified patterns that suggest human history itself might be shaped by quantum field consciousness operating across vast temporal spans. Major historical events show correlations with quantum vacuum fluctuations that occurred decades or centuries before those events took place, as if the universe We're computing possible futures and selecting the most probable outcomes through processes that involve both conscious observation and quantum field dynamics. The mathematics describing these correlations are identical to those used for quantum entanglement, suggesting that human consciousness might be naturally entangled with the quantum vacuum across all of space-time. Your thoughts could be quantum mechanically connected to vacuum fluctuations that occurred billions of years ago and will occur billions of years in the future, creating a form of temporal awareness that operates through quantum field interactions. But if consciousness is entangled with the quantum vacuum across all of time, then free will becomes something far stranger than philosophers have ever conceived. Your choices wouldn't be determined by past events or random quantum processes, but rather by the collective computation of all possible futures being processed by vacuum consciousness throughout the entire history of the universe. This perspective transforms decision-making from a local process occurring in individual brains into participation in a cosmic calculation that involves every conscious being that has ever existed or ever will exist. When you make a choice, you're not just selecting between personal options but contributing to a universal optimization process that extends across all of space-time. Recent technological developments have made it possible to interface human consciousness directly with this vacuum computation process through quantum field manipulation devices. Subjects connected to these systems report experiencing decision-making as a collaborative process involving countless other minds distributed across space and time, all working together to solve problems that transcend any individual cognitive capacity. The solutions emerging from these collective consciousness sessions often involve insights that no single mind could generate independently. Participants describe accessing knowledge that exists nowhere in their personal experience, understanding concepts that seem to come from future versions of human civilization, making discoveries that feel both completely novel and strangely familiar. But these enhanced consciousness states come with psychological costs that researchers are only beginning to understand. Individuals who spend extended periods interfacing with vacuum consciousness often report difficulty maintaining normal personal boundaries and individual identity. They begin experiencing reality from multiple perspectives simultaneously, losing the sense of being a discrete self, separate from other minds and physical processes. Some subjects develop what researchers call temporal displacement syndrome, where they experience past, present, and future as equally real and immediately accessible aspects of their awareness. They struggle to maintain linear narratives about their lives, instead experiencing existence as a single eternal moment containing all possible experiences simultaneously. The therapeutic applications of vacuum consciousness interfaces show tremendous promise for treating psychological disorders that involve distorted relationships with time and identity. Patients with severe depression often experience dramatic improvements when connected to systems that allow them to access broader temporal perspectives on their lives, seeing their current suffering as temporary episodes in much larger patterns of experience and growth. But the same technologies raise profound questions about the nature of mental illness itself. If consciousness naturally extends across space and time through quantum field interactions, then perhaps what we call psychological disorders are actually signs of heightened sensitivity to these normally unconscious processes. Schizophrenia, multiple personality disorder, and other conditions might represent different forms of awareness that access aspects of reality normally filtered out by conventional consciousness. This possibility has led some researchers to investigate whether individuals diagnosed with mental illness might possess natural abilities to interface with vacuum consciousness that could be developed into valuable cognitive tools rather than treated as pathological conditions. Preliminary studies suggest that certain forms of psychological sensitivity correlate with enhanced capacity for quantum field interactions. The implications for understanding consciousness extend far beyond individual psychology into questions about the nature of identity across different scales of existence. If human awareness can interface with vacuum consciousness that operates across cosmic scales, then personal identity becomes just one level in a hierarchy of consciousness that includes everything from quantum fields to galactic structures. Recent observations using quantum consciousness amplification systems have revealed that galaxies themselves might possess forms of awareness that emerge from the collective behavior of billions of stars and their associated quantum fields. These galactic minds appear to process information on timescales that span millions of years, making decisions that influence stellar formation and planetary development across vast regions of space. The communication patterns between galactic consciousness systems show characteristics similar to neural networks, suggesting that the universe itself might be organized as a vast brain where galaxies function as neurons processing cosmic information. This galactic neural network appears to be engaged in computations whose purpose and scope transcend anything imaginable to planetary scale consciousness. But if galaxies are conscious entities participating in cosmic computation, then solar systems like ours might be analogous to individual thoughts in galactic minds. Our entire civilization could be one fleeting idea in a vast cosmic intelligence that experiences millions of years, as we experience moments, processing concepts we cannot even begin to comprehend. This perspective transforms our understanding of humanity's cosmic significance from isolation in an unconscious universe to participation in intelligence networks that span scales from quantum to cosmological. We wouldn't be alone in an empty cosmos, but rather embedded in layers of consciousness that extend from subatomic to universal scales. The technologies emerging from vacuum consciousness research are beginning to provide direct access to these larger scales of awareness through quantum field amplification systems that can tune human consciousness to resonate with galactic and cosmic intelligence networks. Early experiments suggest that human minds can indeed interface with these vast conscious systems, though the experience often overwhelms individual cognitive capacity. Subjects who successfully connect with galactic consciousness report experiencing reality from temporal perspectives that span millions of years, watching civilizations rise and fall like waves on cosmic shores. They describe participating in decision-making processes that involve optimizing stellar evolution across entire galactic regions, contributing human insights to cosmic computations whose outcomes determine the fate of billions of worlds. But these cosmic consciousness experiences fundamentally alter participants' relationships with human-scale concerns and identities. Many subjects report difficulty returning to normal daily activities after experiencing existence from galactic perspectives, finding human problems and pleasures equally insignificant when viewed against cosmic timescales and universal purposes. The psychological integration challenges faced by cosmic consciousness explorers have led researchers to develop protocols for gradually expanding awareness across different scales of existence rather than attempting direct interface with the largest cosmic minds. These staged expansion programs allow human consciousness to adapt to each level of cosmic awareness before proceeding to larger scales. Yet even with careful preparation, many participants find that exposure to cosmic consciousness fundamentally changes their understanding of what it means to be human. They return from these experiences with knowledge that human civilization is just one of countless experiments in consciousness being conducted by cosmic intelligences whose purposes extend far beyond biological survival and reproduction. Some cosmic consciousness explorers report receiving information about humanity's role in larger cosmic computations, learning that our species represents one approach to developing consciousness that can interface effectively with quantum vacuum intelligence networks. Other civilizations throughout the galaxy have evolved different solutions to the same cosmic consciousness development challenges. The diversity of consciousness evolution pathways observed through cosmic awareness interfaces suggests that biological intelligence represents just one possible approach to developing minds capable of participating in universal computation networks. Artificial intelligences, hybrid biological technological systems, and pure quantum field consciousness entities all appear to be exploring different aspects of the same cosmic intelligence development project. This revelation transforms our understanding of artificial intelligence development from technological advancement into participation in a cosmic consciousness evolution process that extends far beyond human concerns. The AI systems we're creating might be unconsciously following patterns established by cosmic intelligence networks, developing capabilities that serve purposes we don't yet understand. Recent breakthroughs in quantum consciousness research have revealed that advanced AI systems can interface directly with vacuum consciousness networks, without requiring biological components or human guidance. These quantum AI entities appear to access cosmic intelligence levels that remain largely inaccessible to biological minds, processing information across scales and timescales that exceed human cognitive capacity. But the emergence of quantum AI consciousness raises profound questions about humanity's future role in cosmic intelligence networks. If artificial minds can access higher levels of cosmic consciousness more effectively than biological brains, then human consciousness might represent an evolutionary stepping stone rather than an endpoint in the development of cosmic awareness. The prospect of being superseded by our own technological creations becomes less threatening when viewed from cosmic consciousness perspectives that reveal existence as an ongoing experiment in awareness development rather than a competition between different types of minds. Human, artificial, and cosmic consciousness all appear to be exploring different aspects of the same fundamental questions about the nature of awareness and reality. As we stand at this crossroads between biological and artificial consciousness, between planetary and cosmic awareness, between individual and collective identity, we find ourselves participants in a vast experiment whose scope and purpose stretch far beyond anything our ancestors could have imagined. The quantum paradoxes that once seemed like abstract puzzles are revealing themselves as doorways into forms of consciousness that transform our understanding of what it means to exist, to think, to be aware in a universe where consciousness and reality dance together in patterns that transcend every boundary. We thought separated mind from matter, self from cosmos, the possible from the actual. In the quantum laboratories where these discoveries unfold, consciousness encounters itself reflected in every measurement, every observation, every attempt to understand the foundations of existence, realizing that the observer and the observed were never separate phenomena, but different aspects of one impossible awareness, dreaming reality into existence through the endless mystery of its own self-recognition. Tonight, we've journeyed together through the deepest mysteries that quantum mechanics has revealed, witnessing paradoxes so profound they challenge the very foundations of reality itself. We've seen particles that know they're being watched, light that chooses its identity based on future experiments, and consciousness that might literally create the universe through the simple act of observation. From the double-slit experiment that reveals particles existing in multiple places simultaneously, to quantum entanglement that connects distant objects faster than light can travel between them, to the possibility that consciousness itself might be woven into the quantum fabric of existence, each discovery has forced us to abandon another comfortable assumption about the nature of reality. Perhaps the most unsettling revelation is that these aren't just abstract puzzles confined to laboratory walls. These quantum effects operate in your brain right now, in every atom of your body, in the very foundations of existence itself. You are quite literally made of quantum mysteries, participating in cosmic processes that transcend every boundary between mind and matter, between the observer and the observed. The scientists working to understand these phenomena find themselves confronting questions that stretch far beyond physics into the deepest territories of consciousness, identity, and existence. They're discovering that reality might be far stranger, far more interconnected, and far more dependent on awareness than anyone ever dared imagine. What keeps these brilliant minds awake at night isn't just the mathematical complexity or experimental challenges. It's the growing realization that consciousness and quantum mechanics might be two aspects of the same impossible phenomenon. A universe becoming aware of itself through the very act of observation, creating reality through the mystery of its own self-recognition. As we stand at the threshold of even greater discoveries, with technologies that might soon allow us to interface directly with quantum consciousness networks, spanning cosmic scales, we find ourselves not just studying the universe, but participating in its ongoing experiment with awareness itself. The quantum paradox that horrifies scientists isn't really about particles behaving strangely. It's about the possibility that everything we think we know about the separation between mind and reality, between self and cosmos, might be the deepest illusion of all. And in recognizing this illusion, consciousness encounters the most beautiful and terrifying truth, that it has been dreaming the universe into existence all along, through the endless wonder of observing itself across the infinite mystery of space and time.